Welcome to Lunch Bunch. Hey, it's May already. Hi, George. Glad you could join us today. Great to see you all. I think my fellow staff members who are on this call today will agree that we're all taking a bit of a respite this week and catching our breath after a very, very busy and exciting commencement week last week. We welcomed nearly 1,000 new grads to our alumni family. And hey, there's lots of parking on campus, so that's good. It's a little quiet. We miss everybody, but it was a wonderful weekend, lots to celebrate, and we're glad that you all have taken time to join us. For those of you who don't know me, my name is Ruth Jones, and I'm with the Minds Foundation. If this is your first Lunch Bunch, welcome. We hope that you'll continue to join us every month. And of course, for those who are regulars, welcome back. We thank you for your continued interest and support. We're excited today to have the spotlight be shining on our Capstone Design at Minds program. And we're going to have an overview of that. For those of you maybe more senior alums on the call, you may remember this as Senior Design. So it's been given a new name, but it's still a fabulous program, and it is a signature Minds program that second to none. We've just come off of this year's design fair, which happened at the end of last month. And we've chosen a few students to share with you their project, the process, their experience. You can ask them questions. We'll do a little show and tell. So before we get started, a few reminders as we do each month. If you did share any questions when you RSVP'd, we've made note of those. If you think of a question during the program, feel free to use the chat. We'll keep an eye on it throughout the hour. If we don't get to your question, we will circle back with you at the end of the program. And as you heard earlier, our Lunch Bunch programs are recorded, and they can be accessed at any time on the archive, which is located on the Lunch Bunch page of our website, weare.minds.edu. And you'll see the events tab, click that, click Lunch Bunch, and you'll see all the programs at the bottom. So if you missed one, if you want to listen again, or if you want to forward it to a friend, there they are. They're all there for you to explore. So lastly, if you have any ideas or suggestions for future programs, please let us know. We'd love to hear your suggestions, and we want to provide programming that you want to hear. So please let me know or contact anybody at the alumni office here on campus. Okay, I'm going to stop talking, thankfully, and I'm going to turn the program over now to Dr. Chelsea Salinas, who helps run the EDS program, out of which Capstone comes. And she'll give an overview of the program, and then we'll get to know some of our students and their projects. So Chelsea, take it away.
Thanks, Ruth. I appreciate it. Well, thank you all for having us. And we're really excited to talk to you about our Capstone Senior Design program here that we run at Minds. And then most importantly, really excited to showcase some of the student work with the students that are joining us here today. So I'm just going to share my screen quickly. And we'll do a quick little overview. So I just kind of prepared an informal little presentation of Capstone Senior Design at Minds to give you a rundown of what our program has evolved into over the years. So for those of you that may have participated in our most recent showcase, it may have looked like this. We had over 69 student projects presenting their year-long work in a kind of a showcase format. So we all piled into Lockridge. Some of us spilled out into the outside parts of the Student Center, and the students were there to showcase the work that they completed over the course of an 8-month period, 2 semesters. So it was really exciting. So thank you to those of you that may have judged as alumni. We really appreciate your contribution to the program as a judge, and then other ways that you contribute to the program. So you may have seen some things like this. This was our design, build, fly team. Some of our teams are competition teams, meaning that they participate in national competitions. For example, we had a steel bridge team that won a regional competition and is now going on to a national competition. And there's also the concrete canoe competition, which had winners that are going on to further competitions. So some of our student projects are competition-based projects, and then others are projects that may run in what we call a design studio. So for instance, one of our design studios is a studio that's focused on projects for people with disabilities. So in this particular studio, the students will work on multiple different projects over the course of 2 semesters and create adaptive equipment for people with disabilities. And this is just one example of those. So these individuals were creating a control mechanism for a wheelchair using just the clenching of your jaw instead of a straw, which is sometimes used. It's called a sip and puff. So this is an example of a project out of that one. So to kind of back it up a little bit, our Capstone at Mines or our multidisciplinary senior design program is kind of multifaceted, and I'll give you a quick overview. So we have over 500 students participating in our senior design program. We are thrilled that we can have and run a multidisciplinary program. So the students that are serviced currently in our Capstone program come from mechanical engineering, electrical engineering, civil, environmental engineering, our new design engineering program. And then we also have some students from physics or computer science joining the teams. The teams then are compiled. The students will start out a semester. So for instance, these students that just presented their showcase this spring attended an expo, a project expo in the fall of their senior year. And they got to kind of peruse all the different projects that clients were offering. And then they got to vote on which projects they were most interested in, or they ranked the projects. They were then teamed. So we like to try and keep the teams nominally around 6 students or so per team, if we can do that. And the clients will actually request different disciplines. So for instance, some clients may request 3 mechanical engineers and 2 electrical engineers on a particular project. And we do our best to make sure that we match client requests with student interest. So the projects that come in are heavily client driven. We have a stakeholder relations manager that seeks out a variety of different types of projects that again, kind of reach into the depths of student interest. There's a huge interest now in aerospace program and mechanical engineering. So we're trying to find projects that really fit the bill for those types of students. There's other students that are interested in automotive or solar or sustainability. And so the projects kind of run the gamut of all topic areas where students are interested. Again, they're multidisciplinary and team members, and we do our best to make sure that the projects themselves are real world. We want the clients to engage with the teams in a way that is open-ended and not kind of solution-driven. That's really where we want our students to come in and develop solutions for the problems that the clients are presenting to them. So in terms of how the program is actually supported, we have generous donations from alumni and other contributions to the foundations. The foundation and monetary donations that we receive in our Capstone program come pretty heavily from foundation support. We do have client-based support. So those for-profit companies that pitch a project for our students will typically pay a certain fee to help the project get underway and then overhead for running the program. But we also accept nonprofit, governmental, local, community member, those types of projects as well. And there's either a nominal fee or we waive the fee and kind of cover that team's budget with foundational support, like I mentioned before. In terms of the timeline, our Capstone program runs around an 8-month timeline. So our students will start in the fall and finish in the spring, just like they did. But we are always running Capstone programs. So we might have students start in the spring and end in the fall. That's what we call our off-cycle program. And we have about 100 students that are enrolled in the off-cycle version, whereas we have about 420 students enrolled in the on-cycle fall-spring version. And in terms of kind of the design aspect of Capstone, usually the students come in, they have an idea of the project, they get teamed, and then they hit the ground running. It's their opportunity to talk to the client, interview the client, maybe investigate, talk to some other stakeholders, and really nail down this project problem. And once they have the problem kind of well figured out, then they go into what we call the exploration phase. So they dive deeper into researching maybe current devices on the market, or perhaps patents, if that exists, and they begin brainstorming ideas within the solution space and coming up or proposing a solution. And once they've proposed a solution, we ask them to actually go through and prove it. You know, we have to do a proof of concept to ensure that the solution is going to meet your client's needs or meet your users' needs. This is really important for our student teams to ensure that what they're doing is going to be successful in the end. So it's a lot of iteration. It's a lot of problem solving, brainstorming, working with your teammates, working with external stakeholders, working with technical advisors within the Minds community. And then once they have everything kind of figured out, they'll start building, prototyping, testing, and applying their knowledge that they've learned in the classroom to a very hands-on type of problem and solution space. So one of the quotes that we pulled from a Capstone client, which I thought was just very fitting, is that the Capstone program is a great opportunity for students to become highly involved with clients and the industry. So I would say that the main point of our Capstone 2-semester senior design client real-world problem-based course is that the students actually get exposure to not only clients and making sure that you're meeting clients' needs, but also to other team members that aren't within your same disciplinary major and within an external industry where you're having to meet certain standards or understand certain standards. So all of these things kind of coming together really help create an environment that the students learn on the ground and take off, and what they complete and what they accomplish is pretty mind-blowing in the end. So that's a quick little rundown of Capstone. I'm now going to hand it off to one of our winning teams, the active gravity offload rig team, to showcase what work they had done to win their Capstone award. So I will stop sharing. And Ben, do you want to take it over?
Yeah. All right. Hello, everyone. My name is Ben Linehan. I was a member of the active gravity offload team. Let me pull up my first thing. Let's see, there it is. All right. So our project was a partnership between the Center for Space Resources, which is a department on campus, and Lunar Outpost. For those of you who maybe aren't familiar, Lunar Outpost is a small startup company in the aerospace industry. And kind of one of their big projects that they have going on right now is their MAP Rover, which is the mobile autonomous prospecting platform. And that is a rover that is actually launching to the moon, the south pole of the moon, in just a little under a year. And they wanted to be able to test their rover. So before our project started on campus, there was a lunar testbed, which is essentially a big sandbox filled with special dirt that's called regolith that is designed to simulate the surface of the moon. And so our project was to, one, expand that test bed. So we increased the size a lot, and also to build onto it and make it better and enable more accurate simulations by building a gravity offload system. So a really important part of launching rovers into space is, you want to make sure that they're going to work exactly how you think. So you need to be able to test them very accurately. So being able to simulate the conditions they're going to be operating in is really, really important. And that includes simulating the gravity. So this is kind of an overview of how our system works. Can everyone see my screen just to make sure? Is that okay? Cool. So this is sort of an overview of how our system works. So essentially, there is a gantry system that sits over the top of the rover. As the rover drives around, a special angle sensor above it detects the rover moving and allows the entire system to track the rover. At the same time, there is a load cell that is measuring the force being applied to the rover and allows the system to adjust and pull up on the rover a set amount to simulate the rover driving at lower gravity. So I will stop sharing quickly and then we'll start again. I have a video of system. Where is it? Yeah. So this is an animation of our SolidWorks model. So this is actually what the system looks like in real life. In actuality, this is about 15 feet by 15 feet squared. So it's a pretty big system. So you can see, I'll start playing the video in just a second, but the entire box is the test bed, and then our offload system covers about 2/3 of it. So it's this corner part right here. So the way the system works is there is what we call a trolley, which is that little wooden platform that you can see right there. On top of that, there's a motor. That is what is applying the vertical force to the rover and pulling up on it to simulate gravity. The other important part of the system is it needs to be able to follow the rover around. You always need to be directly above it, pulling straight up. And so for that, we used what's called an HBOT system, which is commonly used for a lot of 3D printers. This gives you a pretty good view of it. The way the HBOT system works is you essentially have an H of cable. So the cable isn't shown in this model, but you can see all the pulleys. So there are two motors. There's one in this corner and one in this corner. And then there are 6 other pulleys. So there's 2 small idler pulleys on either side of this, and then 2 bigger idler pulleys in the opposite corners. And there is cable running around all of these pulleys in essentially the shape of an H, and either end of the cable is attached at the center here. And the way the system works is by spinning either one or both of these motors in various directions, you can make this trolley move horizontally, vertically, diagonal, pretty much any direction that you want. And so you can see sort of how the system moves. And so that is our rough SolidWorks model. This is a close-up of more of the pulleys so you can kind of see. I will pause this video and stop sharing again. I have another video. We open up. So this is a video of our team doing some actual testing on the real system. So this is the actual built structure. It's located in EMI, which is one of the mining laboratories on campus. It's over behind McNeil Hall and the Geology Museum. So this is a video of us doing some initial testing on the system moving. Actually, in this video, we almost broke a lot of things. It started moving a lot faster than we were expecting. But so you can see in this video, if you look just above my head, that's me right there, the cable. So the motor is straight back in that corner. There's another motor over in the opposite corner. And then you can see the 4 idler pulleys and that thing straight above my hand, that is the trolley. You can see there, it starts to take off. So the way the whole system is controlled is actually pretty cool. So we're using what is called an angle sensor. It looks just like this. So this is the sensor in its mounting bracket. The sensor itself is that little straight black piece right there. It's pretty cool. This little tiny sensor is what controls the movement of the entire system. So essentially, when you move the bottom part of it, it can detect a change in angle from the tip of it up to the base. And then that change in angle is sent to the motors, which translates to motion of the entire system. So yeah, that is a little general overview of our project.
I have a question, Ben.
Sure.
Oop, let me turn my video on. There we go. Hello. So do you fabricate all of the large pieces here on campus, or do you have those made offsite? You bring everything in and assemble it?
No, so the structure of the test bed is built out of what's called 80-20. That's basically extruded aluminum. The reason we use that is because it's really quick and easy to build big structures with. And it's also easily modifiable. It's really easy to add things onto it, which is really important for this project. The Center for Space Resources has a lot of future plans to keep improving the test bed, keep making it better, keep making it more and more accurate. And so it's really important that it's easy to modify, easy to add more things onto.
Very cool.
So that was our choice for that.
Very cool. Thank you. Does anyone have any questions for Ben before we move on to the next project? Okay. Well, thank you, Ben. If you want to hang on, there may be some questions that come in toward the end of the program here. So great job. Great job. Thank you. Okay, next up, Chelsea, if it's okay, do you want to introduce the next one?
Sure.
Okay.
So similar to the JAW EMG team that I showed you in my slide presentation, we have another student from the Human Centered Design Studio. So the design studio where the students work on adaptive equipment for people with disabilities. And Gavin's going to present his project that we titled the Golf Helix. And I'll let him give kind of an overview of that. So take it away, Gavin.
Cool. Hey, everyone. I'm Gavin Jones. I'm a mechanical engineer. And over the whole year, I got to work, like Chelsea said, as part of the Human Centered Design Studio, which focuses on adaptive sports and designing things for people with disabilities. And when I first joined the team, the studio, I knew it was the right place for me because I'm a very hands-on person. I really wanted to be on projects where I could be imaginative and, use my hands to build prototypes and stuff like that. And I actually got the privilege of being on 3 separate teams, part of the Human Centered Design Studio, but my main project that I wanted to focus on was the Golf Helix. And I know that there's a few people in the chat who love golf. I've got my golf shirt on today. It's one of my favorite things to do. So when I saw that there was a project applying to golf, I was the first one to jump on that and try to be a lead for it. And we were able to develop a product over the course of a year for a guy named Bob Radosi. He is the executive vice president of Phil Our TRS Incorporated, which is a company that also specializes in prosthetics and adaptive sport technology. So he approached us. He himself is a transradial amputee on his left arm. And I have a video to show you. I won't explain it all because what I'm saying right now is in the video. So I'm going to share my screen. This is our pitch video for our project. It kind of gives us an overview of everything that we did, the design process that we went through, and then take some questions at the end. So let me share my screen here. Here we go.
Millions of people around the world, including myself, love the game of golf. But there's a group of people out there that just can't enjoy the game like the rest of us. With the help of the Human Centered Design Studio at the Colorado School of Mines and Bob Radosi from TRS Prosthetics in Boulder, Colorado, our group has worked hard to provide a solution for arm and hand amputees to be able to play golf comfortably and just have fun while doing it.
Sure, I'm Bob Radosi, and I'm the Executive Vice President of Phil Our TRS Incorporated. Yeah, I was, I was kind of lucky in some ways. When I was in your age range, I was in a car accident and I lost my hand. I grew up in the 50s, however, and I got to experience lots of different kinds of sports. So when I was a kid, I played baseball and football and all those things in neighborhood and in schools. So I had a pretty good understanding by the time I was 22 of what it felt like to do swing a baseball bat, handle a hockey stick, handle basketballs and soccer balls. So after I lost my hand, I think it gave me the advantage, so to speak, of having already done all those things. So when I started to design devices, I knew what my expectations should be.
TRS's original design for the Helix was more focused on other sports such as lacrosse or hockey, but it fell short in its design application for the game of golf.
When we were first designing the Helix, it was difficult to recreate the complex geometries of Bob's original Helix. Originally, we wanted to incorporate a boa so that I can cinch onto the golf club and have a more secure grip on the club. Unfortunately, the boa requires a closed loop system for it to properly function, and the complex geometry of the Helix only allows for an open loop system, therefore compromising the design of the boa.
With our 6th iteration of the Golf Helix, which was one we felt pretty confident about, we invited Bob to come down and test it at the Varsity Golf Studio. And we were excited at first because things were working pretty well, but then we noticed that there was a tear in the Helix, which looking long-term would not be a very good thing for durability of the product. We wanted to address this issue, and so we decided to run a SolidWorks finite element analysis. We were able to find some data from a study about the forces involved in the hand during a golf swing, and then we used those in our estimations with the simulation. Doing this, we were able to produce results that happened to match our physical testing almost directly. There were stress concentrations exactly where those tears occurred, and which helped us to really figure out how we could address those issues and move forward towards a better Helix. Through a few more iterations, we got to our 8th iteration of the Helix, which we reran that study again using the same exact forces, and we were able to find much better results with not very many stress concentrations. This was something we were really excited about and made us feel a lot more confident when we moved forward with printing and further testing with Bob.
We are finally ready to unveil our finished product, our high fidelity prototype. This is the Golf Helix V8.
Absolutely, yeah, we've gone from a product or a concept that wasn't working in a prototype to one that is now working functionally, at least satisfactorily enough in my mind that I believe we can make this work. It'll perform right. We've got the right angle of incidence, holding the club, the comfort level. It's not too bulky. I can get my hand around it and around the club. It feels reasonably good for getting an overgrasp on, which this requires. And it's got the flexibility. It seems to be replicating the kind of biomechanical motions that I need to effectively swing a golf club.
So yeah, that's our overview pitch video for the Golf Helix. A couple things that weren't mentioned in the video. The Helix that we made was actually 3D resin printed. Oh no, is there something else playing in the background? Okay, yeah, so it's 3D resin printed. And Bob's original design was actually 2-piece polyurethane mold injected. So the future of the project that we want to move forward with when more people come to the Human Centered Design Studio and start on this project in the future is we want them to be able to take our current Helix design, which is 3D printed, and turn it into, change the geometries in a way that we can make it a 2-piece resin mold so that it can be mass produced and eventually be brought to market for Bob's company and allow for people in the future all over the world to be able to play golf if they're transradial amputees. So that's all I got. If anybody has any questions, I'd love to answer.
Yeah, just curious, like on a large scale, Gavin, love the video, first of all.
Thank you.
If that doesn't work out, I would go into making videos for some of these tech companies because as we all know, engineers are not the best communicators. But anyway, interested in the, you know, like on Shark Tank, what they always do is kind of the price model, right? What did this cost you guys to actually make? And then on a larger scale, which we tend to miss a lot in the business world, is how could you possibly monetize this? I know the goal was, you know, to get somebody to play golf, and I understand that, but just interested kind of in that on a larger scale, if you guys have even thought about it.
Sure. So for our prototype modeling, the 3D resin printer is pretty expensive per print. It's not like a normal 3D printer that prints layer by layer with a hollow structure out of plastic filament. It raises it up. You can watch a YouTube video on it. It's a pretty cool process. It solidifies resin into a solid piece. So each one of those prints probably costs between $10 and $20. So we've made 8 prints. So that is not very, that doesn't really hold up in the long run for mass producing them. But Bob explained to us that transradial amputees are actually one of the largest, for disabilities, one of the largest markets for adaptive sports. The largest market is people who have amputations on their arm, and more specifically the transradial. So Bob has his company already, and he lists a lot of different products on there for downhill ski racing, and which is another project part of the Human-Centered Design Studio, and all these products that he lists. But he explained to us that making this polyurethane resin mold, he can get the price per piece down under $1 to create, maybe $5, just cutting our costs in half, just because they can really, the polyurethane that they use is actually pretty inexpensive compared to these 3D modeling resins. So he can just produce these a lot quicker and a lot cheaper, which is why he was so interested in approaching us, was he wanted to first create the design that worked and then bring it to market himself through his company, which we help him do. Does that answer your question? Do you have anything else that I missed?
No, appreciate that. Thanks.
Cool. Anybody else?
Okay, well, I can introduce the next student. So David Kenke is here from Sustainable Power Systems was his team. And he's got a really great story talking about how he and his team worked on creating an entire house that was completely sustainable, and one that might be built in the coming months over at Mines Park. So I'll kick it over to David to tell us a little bit more about his project.
Yeah, hey everybody, I'm David Kenke. Yeah, so the house is planning to be, will start being built in February. They actually won from the Solar Decathlon Challenge, so it's actually going to be incorporated in the build process. So that's pretty exciting, because for us, it was essentially just a, thank you. It's essentially just a design challenge for us. So we made the energy systems for the entire house, and we worked kind of as almost like a contract designer with the actual Solar Decathlon team here for Mines. And so I will pull up just our general poster, and I can show you through the different areas here. So if you guys can all see that, this is the actual house here on the left. That roof is about 18 degrees, and it's going to be facing directly south. So we'll have about 8 kilowatts of PV on there. And the first step with our energy design was the energy analysis of the house. So you can see over here, these charts here show the different energy analysis that we ran. One was without geothermal, and essentially we found that water heating and heating the house was a really intense load. So that was one of the first things we had to basically work on as a team, was figuring out how to alleviate that that heavy draw of energy. So we incorporated a geothermal unit. It'll be about 300 feet in depth, and it's going to be vertical. There's 2 different types. There's a vertical and a horizontal bore. So we'll be doing the vertical bore, and that is going to be like a 2-ton. So they have these different ranges of how much fluid essentially is going down, and it affects the heat transfer of it all. So for this, for the square footage of the house, we figured out a 2-ton was all we needed. So as you can see, there's several different systems that needed to be designed to make this house work correctly. There's a smart system. There's the PV as the energy generation. We did solar thermal and something called a D-superheater for water heating. And for backup energy, we had batteries. We used Nissan Leaf batteries. So we're going to recycle those from the electric vehicle, and we put them in parallel in series. There's 7 in series, and 6 of those are in parallel to create about 19 kilowatt hours of energy storage. And again, that was kind of one of the most innovative pieces of our design, was just to use recycled electric vehicle batteries. The reason that they work for houses and not a car is that cars they need a lot of amperage, and over time the battery just kind of doesn't provide the amperage that the car needs. But they still work really well for what a house needs, because it doesn't need that heavy acceleration essentially that a car does. So anyway, the batteries will be fed from the solar PV system, which you can see here in the middle. It will be grid tied, and the inverter will also be connected to a critical load. So the critical load is going to be if there's a blackout essentially, or if they need us to go off grid, like we'd be working with Excel essentially with it. And we can power certain aspects of the house through this critical load panel. And then like 90 something % of the time will be connected to the grid. So that would be pretty standard with that. There is about 27 panels, solar panels on the roof, and there is one solar thermal panel. It's 30 evacuated tubes. That will all be located on the roof. And all this will be, you can see this when the house is built, at least the external components you can see. And with the solar thermal, we have a double heat exchanger water tank, 80 gallon. And so the fluids just both from the desuperheater, one has a heat exchanger from the desuperheater, and then the other has a heat exchanger from the solar thermal. And so that just cycle through the water heater, and that allows essentially the hot water needs of the entire house. And there's a backup 4.5 kilowatt heat resistance in this water heating tank. So again, those are really important, was getting the heat and the cooling from the house and the water heating taken care of, because otherwise our system wouldn't be able to supply the load essentially. Yeah, so that's essentially the whole system. There is a smart system incorporated, so we can kind of control lights, and we can control settings of times that something will kick on. Like if, for instance, this is going to be made for 4, this house will be used by 4 students. So we can kind of assume that midday, that might be a good time to power something, especially with all the PV generation. So we could kind of have triggers that maybe run a dryer or something at a given time with the smart system layout. So anyway, that is essentially the macro perspective of what we did. And all these systems essentially came together to be the energy system they needed to make it work. So see if I can, were you guys able to see that? I apologize. I don't know if I shared that.
You did.
All good.
Okay,
Yeah.
okay, sorry, I Zoom just messed me up there. But yeah, that's essentially the background of the house, and you guys can probably check it out in 2023, late 2023, just in Mines Park. But yeah, if there's any questions or anything.
Yeah, just curious again on the kind of financial side, David, great little poster you got there. What's kind of the cost of all these add-ons, to make the house versus just a normal house? I'm sure you guys modeled that, and, in the long run, how does that kind of look?
Yeah, so the PV system with everything was around 20,000 or so. A lot of the stuff was actually, like, the PV panels were actually supplied by the client. So we did have like certain aspects that we didn't have to calculate for, but the geothermal was certainly the most expensive component of the house. And it also is kind of doing the most essentially for the heating. But other than that, I think the total was around 75,000 for all the energy components. And yeah, so I guess, there's a payback period related to that. the client is actually ran the numbers on the payback period of it because they just wanted us to get the most efficient design. So, but that's kind of the ballpark essentially.
So I'll ask a question. Did you think about doing anything other than batteries, like compressed air energy storage, in particular in conjunction with putting a deep vertical geothermal well? You could probably piggyback compressed air energy storage in that.
Yeah, that we did not look into compressed air storage, but I like that. We did have a brainstorming session in our initial design phase. So we had some pretty wacky designs, honestly. There was a swimming pool for pumped hydro. So it was like a double functioning.
Yeah, not a whole lot of head there. Yeah, but
yeah, exactly. It was, yeah, we had to, yeah. So certain things were just kind of like concepts and ideas. And then certain things were just kind of for the sake of thinking about it thoroughly before we just settle for something that's kind of standard. At the end of the day, you know, standard is standard for a reason, kind of. So it's just, I think it's just somewhat cost and space and all these type of things. Wind is not an option. We noticed that wind is not an option here. So, but yeah, we did not look into compressed air. So.
Okay, something for the future. Thank you.
Yeah, thank you. Appreciate it.
David, I see a question in the chat from Sam about who gets to live in the house and what's the monthly rent?
Yeah, that's a good question.
Yeah.
Well, it's for students. I do know that, and there's 4 bedrooms. Whoever has a environmentally conscious mindset would be good for the house, I would say, because there are going to be some, you know, that they're gonna kind of want to have the smart scheduling system and whatnot. They're gonna have to want that to live there a little bit. But for the most part, it's pretty standard, comparable to a normal house. I don't know the monthly rent. That's a good question. I guess it would be just similar to whatever else Mines Park pays. I do know that they're going to show the house off. Like they're going to use it as kind of an example of kind of the direction I think Mines is trying to head towards a little bit. So I'm not sure. Yeah, we'll see.
All right.
Awesome.
I wanted to jump in here real quick, everybody, and I hope I'm not putting Christy on the spot, but wanted to say hello to Dr. Christy Savina, who's with us today, who I know is over the years very involved with many of these projects as a member of the faculty of the Mechanical Engineering Department. And you just heard Dr. Priscilla Nelson also. So we've got some faculty with us, and I thought I would just open up the floor to you two, if you might want to make any comments, or, you know, if you have any words of wisdom for the good of the order for those on the call.
I joined because I'm lead instructor for mechanical engineering, and Chelsea and I teach the course together, and then we have our subsequent projects that we are project advisors for. So I wasn't an advisor for these, but we had some remarkable projects this year. I was just chatting with Mary, who's on the line, about our showcase. And if you ever have an opportunity to attend our showcase, I know the invitations go out, but we had some great solutions that were provided. Milwaukee Tool has been a strong partner with us for the past several years, and we had some great projects there. Craig Hospital has been another company company client who has given us several projects every year. And it just shows the diversity of the types of projects. I love what was showcased here because it shows you the different types of projects where our students are having impact. So it's a privilege for me to be a part of it. And we really appreciate these really diverse projects that are coming from our clients and from industry.
That's
Thanks,
great.
Ruth.
That's great. And I want to volunteer for Chelsea. I know that there have been some projects that have been funded or brought to the program by mining companies, but there have been no mining students involved because mining does not participate in this program, much to my chagrin. So I argue about it, but I think that I'd be happy to work with. I know Rob Reeves has been working with you on several of those. And I wanted to ask a question as well. I can't remember who it was who was presenting about the spiral in the Gulf. The idea of including any kind of a fiber reinforcement in that resin. In particular, I'm committed to the future of basalt fibers. Basalt is an igneous rock, like lava in Iceland or Hawaii, and you can go to eBay right now and get basalt fiber, and it's stronger than steel. And I think it would be possible to incorporate it in 3D printing. So just to think about maybe trying to put some point reinforcement in those stress concentrations might be something really interesting, and I'd be happy to talk with you about it.
That's awesome. Thank you.
Yeah, thanks, Gavin.
Sure.
I also want to put in a plug for the amazing alumni judges who participate in this program each year. They are given access to the fair early on before the general public, and they visit and ask questions of these students and help, I think, judge and grade their final project. So it's a really great and fun way for our alumni to engage with students directly on what they're doing. And I know the students love to pick their brains as well. So it's two-way, a lot of fun. So for any of you on the call today, if you might be interested in volunteering as a judge in the future, I hope you'll let me know and we can get you set up. Okay, does anyone have any other questions for our speakers or for our faculty who are with us? Okay, I would like to give a plug, as I always do, for Lunch Bunch for next month's program before we close. For those of you that may have joined late, as I said, Lunch Bunch happens on the third Thursday of every month from noon to 1. These are all done on Zoom now. We may see a day when we go back to in person, but we kind of like the Zoom format. We can engage a lot more folks and you don't have to be in Golden. We have people from all over that join us each month. So we encourage you to come back. Next month, our program will be on Thursday, June 16th, again from noon to 1. And our focus will be the Women of Minds interest group. And so you will hear from alumna Andrea Passman, who chairs that group. They've got some remarkable energy and enthusiasm, and they launched their inaugural Women of Minds networking gala that happened back in March. And they've got some pretty great plans. Certainly as we work to reach our strategic goal of increasing female enrollment here at Minds, this is part and parcel of that. They're an amazing group, so you'll want to tune in for that. Again, you can RSVP through our website. You'll hear about it through the alumni newsletter as well, but we encourage you to log on and join us. Chelsea, do you have anything that you'd like to mention as we wrap up before we close?
No, just kind of another thanks to all of you for joining us today and listening as we showcase our student work. And then also a huge thanks to those of you that contribute to our Capstone program in any variety of ways, whether you serve as a judge or your generous donations through the foundation really help to keep the program running and so successful. So thank you all for that.
Awesome. Thank you so much. And thanks everybody for being here. I do see one last question from Stefan in the chat about subscribing to the alumni paper. We don't have a newspaper per se. We do have a monthly newsletter that goes out via email. Stefan, if you are an alumnus, you would be receiving that automatically. If you are not, I believe there might be a way to add your email to our mailing list so that you can be apprised of what's happening. If that's not possible for whatever reason, I will remind you, you can always visit our website, which is weare.minds.edu. And everything you need to know about alumni programs is listed there. So that's a great resource for you as well. Oh, and you graduated last week. Well, hey, congratulations. So you're officially on the mailing list now. I don't need to add you, but you'll get those every month as going forward. So, okay, everybody. Congrats to the seniors on the call. Amazing projects. Thank you to the faculty who joined us today. We appreciate your time. And Chelsea, thanks for the very informative interview. It's such an awesome project. I look forward to it every year when this happens, to see the amazing projects that come out of our students. So have a great day, and we will hopefully see you next month.